Let's look at the solution of algebra by now. The expression something 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 divided by something something when divided by x minus 8 is a positive integer for x not equal to 3 or minus 2. What is the largest such value of positive integer x? Okay. First thing you do is we write this expression now. X cubed plus 7x squared minus 14x minus 48 whole thing divided by x square minus x minus x. Now see, breaking down a quadratic expression is difficult, but breaking down a cubic expression is difficult, but breaking down a quadratic is easy. Can you happily see in the denominator you are going to get x plus not plus 3, x minus 3 and x plus 2. Once this is identified, now you have a good hint for what values to check for the cubic expression given in the numerator. Put x equal to 3. X equal to 3, you will get 27, 63 minus 42 and minus 48. Yes, you are getting zero summation here, so x minus 3 is a factor of the expression at the top. Now put x equal to minus 2, you get minus 8 plus 28 plus 28 and minus 48. So altogether we still get a 0. So x plus 2 is also a factor. Once you have identified this much, x minus 3 and x plus 2 you have identified. Hopefully you can also identify the third factor straight away. Coefficient of x cube is nothing, so this is simply x plus or x minus something. And the product of roots is given to me as minus 14. Product of roots is given to me as, minus 48. I already have minus 6. In order to get to minus 48, this has to be the third factor. And given this is the entire expression, I can cancel these portions out. I'm left with x plus 8. I'm left with x plus 8. And the question told me this upon division by x minus 8 gives us an integer. I can rearrange the terms and get x minus 8 plus 16 divided by x minus 8. Now this part here will give me 1. What I'm left with is 16 by x minus 8. Now x minus 8, because this entire result is an integer, x minus 8 has to be a factor of 16. The largest factor of 16 is 16 itself. X minus 8 has to be 16, or x has to be equal to 24. Okay, next one. P and Q are two distinct positive integers which satisfy the equation p square minus q square is equal to 337 minus 4p. Find the product pq if p is greater than q. Okay, so let's see. There are two hints that you should see here. One is the presence of minus 4p here. When it goes to the left hand side, it will turn to plus 4p. And the fact that q square has a negative sign ahead of it. We will incorporate both those things by doing this. P square, I've got plus 4p. Additionally, can you see if I want to complete the perfect square here, I'll simply add a 4. But this adding of 4 cannot go without compensation. The compensation would be on the right hand side. To 337 also I will add 4. To 337 also I will add 4. Next I have is minus q square here. And now hopefully you can see this has turned into p plus 2 whole square minus q whole square is equal to 341. I can break down the left side as p plus 2 minus q and p plus 2 plus q. You can basically break down the expression on the left hand side into two separate factors, two numbers that are multiplied. In how many ways can I write 341 as product of two numbers? One way is 1 into 341 and the other way is 11 into 31. These are the only two ways available. So let us first work with 1 into 341. If that's the case, now see identification wise what is important. Can you see this is going to be the smaller number, and this is going to be the larger number. In fact, directly from here, plus 2, after adding a plus 2, p minus q plus 2 leads me to 1. Can I say p minus q should be equal to minus 1? If I add a plus 2 here, it will turn to 1. But can you see, as soon as you arrive at this point, this is unacceptable because the question told me p is greater than q. So p minus q cannot be a negative number. P minus q cannot be a negative number, which tells me this pairing will not work. Only the second pairing will work. Let me go ahead and write that down. 11 into 31. And now this is wrong. P minus q should be equal to plus 2. This should be equal to 9. And then p plus q should be equal to 29. Basically, see this expression here, p plus 2 plus q is equal to 31. 2 and 2, if I take out, p plus q is equal to 29. Now I have 2p is equal to 38 or p is equal to 19. If p is equal to 19, q should be equal to 10. At p 19, q 10. Finally, I was asked the product of pq. The answer will be 190. Next question, if x is equal to under root 2 plus 1, then find the value of x square plus 1 by x square. Okay, x square plus 1 by x square. I need whole squaring of this. First thing I need is, I already have the value of x, so let me just square it up anyway. I get x square is equal to 2 plus 1, 3 plus 2 root 2. X square should be equal to this. So this will turn to 3 plus 2 root 2 plus 1 by 3 plus 2 root 2 whole thing whole square. Now when you're trying to whole square this, one cardinal rule of algebra that is not told to us: as long as you have irrational terms in the denominator, you cannot be squaring or doing anything with the entire expression. You have to make sure that this expression is rationalized. So we get 3 plus 2 root 2. The portion on the left remains the same. Here what we'll get is 1 by 3 plus 2 root 2 into 3 minus 2 root 2 by 3 minus 2 root 2. We are simply trying to rationalize the right hand side, this whole square. The denominator here will turn to 9 minus 8 or is as good as 1. So effectively, see the denominator here, this into this. A plus b, a minus b. So 3 square minus 2 root 2 whole square is 9 minus 8, 1. So what we are left with is 3 plus 2 root 2 plus 3 minus 2 root 2 divided by 1 whole square. So can you see this 1 is useless. So I don't need this fractional implication. This 2 root 2 gone, this minus 2 root 2 gone. I'm left with 3 plus 3 whole square, or I'm looking at 6 square. So my answer has to be option D, 36. Next question. If P and Q belong to real numbers and P square plus 2PQ plus 2Q square minus Q minus 6 is equal to 0, then find the sum of the minimum and maximum value of Q. Again, I would implore you look at this expression. Can you see P square plus 2PQ? All you need to check is, oh, if I had one more Q square, this will be P plus Q whole square. And what are we left with? We are left with Q square minus Q minus 6. This is equal to 0. So this turns to P plus Q whole square. And this is Q minus 3 in Q plus 2 is equal to 0. Now for a perfect square plus something to turn out to be 0, for a perfect square plus something to turn out to be 0, can you see this part here has to be 0 itself, this part here has to be 0 itself, and now what we are left with here is Q has to either be equal to 3 or Q has to be equal to minus 2. These are the minimum and maximum values of Q. These are the minimum and maximum values of Q. Because if I simply draw a graph for this second part, it will go something like this, 3 and minus 2. Anything beyond that, you are getting positive results only. So minimum and maximum possible value of Q will lie in the range 3 and minus 2. The question only asks me sum of minimum and maximum value of Q. The answer will turn out to be 1. 3 plus minus 2. 3 plus minus 2. Okay, next question. The quadratic polynomial gx is equal to x square plus bx plus c takes a minimum value of minus 13 and g0 is equal to 3. Anytime you see g0, gx something, this means as good as c is equal to 3. Because when you put x equal to 0, this entire expression will have only c left. And we have been told this polynomial takes minimum value of minus 30. Minimum value is obtained when x is equal to minus b by 2a. In our case, we have b, so it is minus b, but a is 1, so minus b by 2. Let us just put it in the expression directly. So we'll have b square by 4 minus b square by 2 plus 3 is equal to minus 13. This was minimum value was equal to minus 13. It will help me get to an approximate value of b. So let's see. 4, so I get b square by 4 minus b square by 4 is equal to minus 16. So this and this one. So b square is equal to 64. B should be equal to 8 or minus 8. B can be one of those two values, not a problem. So my final expression is either x square plus 8x plus 3, or the other expression is x square minus 8x plus 3. Let us simply identify the roots here. Roots would be equal to minus 8 plus under root 64 minus 12 by 2, and the other root would be minus 8 plus under root, it's not plus. In this case, it will not be plus. I'm so sorry. This will be minus 64 minus 12, whole thing divided by 2. Finally, I needed the difference between them. So I'll take difference. Can you see this portion of minus 8 will get cancelled anyway? Will get cancelled anyway. And then what are we left with? We are left with root 52 by 2 plus root 52 by 2, because this minus, these two minuses will interact with each other and turn to positive. So I'll finally be left with root 52 here, which is equal to 2 root 30. Now at this time, a decision making needs to be engaged in. Do I go ahead and mark option C as the answer, or do I wait to also solve the second version of it? You should go ahead and mark the answer, because can you see all the 4 options are precise. Had there been a cannot be determined, there would be a possibility of another answer. But the fact that all 4 options are precise, you should simply go ahead and mark the answer here. Okay. For peace of mind, I will also work with -8. Can you see? This time you will get 8 plus root 52 by 2 minus 8 minus root 52 by 2. This b portion gets cancelled out anyway. So finally we are left with this gone, this gone. We are left with root 52 all over again, which is equal to 2 root 13 all over again. We'll mark option C as the final answer. But even after you reach two potential values of D, you don't really need to solve it for both those cases, for the simple reason that all the four options are precise. That will be all for this episode. Hope you learned something. Okay, bye.